So in Rob's comment, students focused more on the manipulation and they don't have any words around it. And I asked students why they did that. So I went back and tracked students and asked them, why did you just put no words and just the equations? And I think the conclusion we came to is that's what was graded before until this time. So there was kind of an unhealthy fixation on just playing with the equations and not writing any words around it. The second thing about what Carlos said is it takes a lot of time to figure it out, and you have to mess up. There's no way to learn writing proofs, or I guess learn anything unless you mess up. You mess up, that's when you learn. When you get it all right, it's kind of like you don't really internalize it. But get it wrong, you're like, holy cow, I got that wrong. And you start to think, what can I do different not to get that wrong again? Using one hammer for all proofs. I mean, I don't think I've had that problem. It might depend on a personality. There might be people out there that try that. Contradiction always. I've had a few students who do that. Everything was a contradiction proof. That won't work. You have to think outside the box. You have to look at each problem as a new problem. And that's really hard because that's not how you were taught up to now, right? You were shown an example and then you're supposed to do that example. And then you're shown another example and you're supposed to do that example. So that's really different. Every problem's new and you have to think. And confusing the know and the show. You write clearly, you won't confuse the two. So I'm going to write that proof up as if I was teaching a class where I wasn't showing you the background. I'm just going to present it. That's a presentation. That's different than teaching how to do it. So here's that same proof. Written in prose. Suppose that D divides A for some integer, then by definition, I didn't cite the page number, I said just by definition of divides, we have A equals D times T for some integer T. Multiply both sides of this equation by the integer C to obtain math language, right? You see all this language in your textbook. Notice I reference everything as I'm doing it. Every step is logically explained. CA is DCT. I can rotate that around because of the associative property of multiplication. Let S represent the integer obtained by multiplying C and T. Then CA equals DS. Since CA is equal to the product of D and some integer, by definition of divides, D divides C times A. So you don't see all the scratch work and the messing around to get to that point. It just, every line is logical. And a well-done proof, it's like a work of art. It should be clear as a bell. It shouldn't have too many words. It shouldn't have too little words. It should be just right. And anyone can cheat off of you because they don't have to ask you a question. They know exactly what you're talking about. Okay, questions? If you're afraid to be on YouTube, we had a thing in linear algebra, we would just say that it was Tyler, but he's not here, right? Hi, my name is Tyler. I have a question. Oh, was that clear? Really? All right, let's get to the not breathe part then. I just picked one from the book. I go through the policies, but the way I work is Mondays we have in-class assignments where you get to practice things in groups, and we'll all get to know each other. Even if you didn't write things on the back of that last page, I'll find out. I'll know about you at the end of this. We'll all get to know each other, work in groups, and get a chance to work and not just listen to me the entire time. On Wednesdays, we always have quizzes.
Every Wednesday?
Every Wednesday. You won't be bored. Step one, write down the no. That's easy. Scrap out the part between if and then. Strict inequality. Cut off the if and the then and just splice out that piece. What I know is that this has a rational root, and I start to expand it out of habit. What does rational root mean? It means that the root takes the form of a fraction. That's what it means. So I wrote the fraction. I can't help myself. I just start to go to the next thing. And this is all going to be online, and you also get the PowerPoint. So if you're trying to keep up, don't worry. And I put it on the next page, so you don't have to keep a record. You can see it. What does it mean to be a root? I'm expanding more. You ever help? I saw that some people teach. You ever help someone with algebra and you say, you see them get the wrong answer and you want them to understand they got the wrong answer? Just plug it back in, right? You tell them plug it back in. And that's when they plug it back in and they don't get the thing they're supposed to get and they don't understand why you asked them to plug it in and you're like, oh boy, oh boy. Let me look for that superhero teaching skill somewhere. So you can plug it back in, right? A root means that it makes the equation 0. So that's what I know. Good? My mom could cheat off of me if she was in this class. So that's my no flushed out. What I have to show is that P over Q is an integer. Well, when does a fraction become an integer? 4 over 2, right? When does that happen? The denominator has to divide the numerator. So equivalently, expanding, this is what I mean by expanding my show. Equivalently, the same thing is that I have to show that the bottom divides the top. I have a definition for that. That means I have to show that P is equal to Q times T for some integer T, blah, 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 blah. She's like, I'm not going to pretend I'm bored anymore. So this is my no in equation form, the stuff I'm going to play with, and I need to get to that. So I need to start from here and get to there. So don't take notes now because I'm going to show you some false starts. I'm just messing with it. Well, my first idea was clear fractions because the reason I would do that is because the thing at the end has no fractions in it. So maybe if I cleared the fractions out, it's going to get me somewhere. And I get P squared is Q times that mess. And I'm scratching my head thinking, what does that tell me? Well, it tells me Q divides P squared. Is that what I needed to get to? So I start thinking what that means. What is this something? I don't know. Is it possible for something to divide a square and not a factor? And I soon came up with an example of, yeah, it's almost nothing. I found almost nothing. Because 8 divides 16 by 8 doesn't divide the original thing. I keep notebooks and I actually write my swear words out in the notebook. I write everything in the notebook. So I have notebooks full of mistakes. So that led me nowhere. So is that a dead end? Let me go back to this. I know that the P divides this piece, right? Because P is, I just proved that. But does P divide this piece? That would tell me something more. And I mess around with it for a while and I'm not able to show anything more on that lead. So that lead didn't turn out to be something. Okay, so those two leads take time. They take time to mess around with it. And you can easily be sitting there and look up at the problem and go, oh, I've only been working on one problem this entire time and I still haven't got anywhere close to the answer and all my leads are wrong and I don't know what to do. That's part of it. That's part of learning. Because once you do this here, you'll realize what to do for a different problem. It's the kind of like every time you do one of these, you get stronger and stronger and stronger at it. So now I'm going to try a different approach. I'm going to go back to the table and say, I'm not going to try to go directly to this. I'm going to use contradiction. Either Q divides P or it doesn't. That's a black and white, right? So I'm going to assume that it doesn't and see if I can come up with some flaw in logic. So I start out with assuming Q doesn't divide P, which is I'm supposed to show Q does divide P. And so I assume the opposite. And see if I can, if it doesn't divide it, then I can reduce it, right? I can reduce the fraction P over Q. So I can assume without any loss of generality that these two things don't divide each other at all. If they're in lowest common denominator, is it possible for Q to divide P squared? That was where I was starting, right? And I'm also thumbing in my book. Is there anything in there that will help me? And I find, oh, on page 8, there's a corollary that says exactly that. If Q doesn't divide P, is it possible for Q to divide P squared? Well, I took this theorem right here. And what it says is, if these two things are relatively prime, that means that they don't have any common divisors, and Q divides P squared, then Q has to divide P. So this is how I'm going to develop my contradiction. If you don't see it yet, I'm going to show you how it works. Here's the lined up proof. So I'm going to assume on the contrary that P over Q is not an integer. Q does not divide P. If Q does not divide P, we can assume it's reduced and that P and Q have no common factors. Because P over Q is a root, it solves that equation. That's the first thing I wrote down, right? But if I did that business, now I've shown that Q divides P squared. Therefore, by the definition, Q divides P squared. That was my erroneous conclusion earlier, which I'm going to use now. Since Q and P are relatively prime, by the first corollary, I get that Q has to divide P, which is a contradiction to what I assumed, that Q does not divide P. And so there I have it. That contradicts our assumption that P over Q is not an integer. Roundabout way, right? Did it. A little bit more messy. Breathing. How do I ask these kind of questions? I ask them, here's a sample problem. I ask you to flush things out. I give you credit for writing down the no. I ask you to expand what you know. I ask you to write down what you have to show. I ask you to expand what you have to show. And then the meat of the proof. Especially in the beginning, I lean more points towards just getting the cut up right and knowing what to put where. So at each step of the way, I know that you're learning. And I don't expect you to bang out proofs right and left the first day. So this gives you kind of an example of how I have the rubric on the side. I do have the complete sentences thing because I just need to get in the habit of using, like Rob Vallon said, you have some words and some messing around, and you put the two together to explain yourself. It is about clearly explaining yourself.